Hello, good evening, or good morning, whatever time you're watching this video. I will be giving you some questions that will serve as your review for your exam tomorrow. So let's begin with the first question that I will show to you. This item in your exam, as I noticed, there's something wrong with the question. So using this figure here, and then you have calculations there below to get the torque and radius of the third force being added in our um, system. So we have our first force here, and then we have our second force, and then we have negative 10 Newton force, which is already given in the problem. But then again, it asked for the magnitude of the radius and the direction of the third torque. And if you notice in our options, we have um, values or magnitude to our third torque and even the radius of the torque. Where in fact, if we will be calculating it, this system is already in equilibrium. The total torque is equal to zero already. And then there's no answer in our uh, question. So this will be considered as a bonus. And I am requesting everyone to just shade option A on your zip grade answer sheet. Again, this problem or this question has some discrepancies and errors. I never check it before I include it in our examination. So there's no answer here, and I am requesting and demanding you to just shade option A if you will encounter this during your examination. Next, we have 2-point masses gripped to a 2.7 kilogram rod whose center axis is at the center. Please be mindful that the rod is not massless. It has a mass of 2.7 kilogram. Then we have a 2 kilogram point mass at 0.30 meter from the center axis, while the other 3 kilogram point mass is at 0.50 meters. And let's figure out the MOI. We just need to add the total MOIs of the following point masses and extended object, like the rod. And always remember that the formula to get the MOI of the rod when the axis at the center is 1 over 12 ml squared. And to get the length, all you have to do is to add the length of the point mass 2 kilogram, which is 0.30, plus the distance or the length of the 3 kilogram mass at 0.50. Okay, and when you input that one to your calculator, the MOI of the 2.7 rod at the center is 0.144 kilogram meter squared. And we still have 2 point masses to calculate. So the 0.2 kilogram mass and 3 kilogram mass. All you have to do is to add them. Since they are point masses, we will be using the formula mr squared. Just input all the needed uh, given variables to this equation and then you will have a sum of 0.93. The next thing you will do is to add add the MOI of the rod and the total MOI of the point masses, and it will give you a sum of 1.074 kilogram meter squared, and that's option A. Next, the net torque acting over a time interval is called blank. The answer for this statement, we all know that when we say net torque acting over a time interval, it doesn't mean that we will have to divide the net torque with a time interval. It means that the net torque acting when the time is running at a certain seconds or duration or minute. It's not division. So the net torque acting over a time interval is called the angular impulse. Okay. And next, which of the following describe the tangential acceleration of a point on a rotating body? So you have option A, it equals to this RA and acts along the tangent. And you will have this one, the radius multiplied by the angular velocity and acts towards the center. And then you will have option C, it equals to the angular squared multiplied by the radius and acts radially outward. And then letter D, it equals to the angular acceleration over the radius and acts opposite rotation. The answer for this question is A. It equals to the radius times the angular acceleration and acts along the tangent. B is incorrect because that's the tangential speed. And the question talks about what is the best option that describes tangential acceleration of a point in or on a rotating body. So C is the centripetal acceleration, which acts radially inward and not outward. And tangential acceleration is like the direction is outward. Okay, so letter B is not the right answer. And letter C is not the right answer. Letter D, it's dimensionally incorrect, and the units don't match the acceleration if you will be using this formula. So the best answer for this item will be A. It equals to the radius multiplied by the angular acceleration. According to the Newton's law of universal gravitation, the force of gravity between the two objects depends on. The correct answer is letter D, their masses and the distance between them. That's the answer for this. When you will review your Newton's law of universal gravitation, the force of gravity between the object will depend or dependent to the following variable, their masses and the distance between them. The period of a simple pendulum is dependent on blank. The answer for this item is letter C. The length, it is dependent on the length of the string and the acceleration due to gravity. To get the period of a simple pendulum, the period that I discussed to you in terms of SHM, I never discussed about pendulum, but the restoring force in terms of spring. So the answer for this, the period of a simple pendulum is always dependent on the length of the string of that pendulum and the acceleration due to gravity. Which of the following situations produces the greatest pressure? Um, you know what? Pressure is greatest when the area when the area is or the area applied by the being applied by the force is lesser. When you have lesser area, the pressure will be greater. So among the options here, which one has a lesser area and force is applied there? A baggage full of clothes placed on your lap, the baggage full of clothes on your lap, this has greater area. Hollow block resting on your chest, hollow block has greater area. Sharpened pencil pressed against your hand. The tip of the pencil is having lesser area, and when you will have lesser area, the pressure will be greater. And next option, a steel ball, it's having a greater area. Among the four options, letter C is the answer. It has a lesser area, so it will generate higher pressure. Which among the following situation produces greatest pressure? All the options experience pressure, but it is greatest um, in situation C because of a smaller area. Here's the thing, I guess it's a familiar question during your culminating test. You overheard your classmate whisper about how easy the culminating evaluation was, even though they were seated 3 rows behind you. The behavior of the sound could explain this. Is a phenomenon called diffraction. It's not echo, it's not the bending of sound due to temperature difference, and it's not combination or this construction or destruction of waves. So the correct answer is diffraction. The reason why, even though someone is talking, you cannot see the person talking, but you hear uh, the talk. So that's diffraction. The sound wave will enter to small holes of your window or cracks or opening. The sound wave outside will enter and you can hear a soft or low intensity of sound. That's diffraction. Assuming that the temperature is constant as the sound wave propagates among the matter in the options, which one sound which one sound travels the fastest in accordance with elasticity? Elasticity is the property of a certain matter that is um, described as it can be easily be back to its original position. The atoms will be disturbed and then go back easily to its original position. Soda is a liquid, and elasticity in liquid, since atoms are spread a little bit, so it will not be easily be back to their original position. Oxygen gas, the atoms are very far from each other, so it cannot be easily um, the atoms cannot be easily uh, be back to their original positions. You have the steel, form of metal, and the atoms there are very, very compact compared to wood. Both these are both um, solid materials, but metals compared to wood, it has a higher elasticity, so it can be easily be back to its original position. The atoms of the steel will be easily back to their original position, so it has higher elasticity. So the sound will travel very fast in that case. So the answer is steel. Which of the following describe a transverse wave? During our discussion, I am talking about longitudinal wave because of sound physics, but a transverse wave is opposite to it. Sound is not traveling in a transverse wave. Energy in letter A, energy transfer is parallel to particles vibration, and this is a characteristic of a longitudinal wave. So this is not the correct answer. B, it consists of compressions and rarefactions. This is also a characteristics of longitudinal wave. So it is not the answer. Transverse wave, it has trough and crest. Up, down, up, down. So the energy transfer is at right angle to particles vibration. This is now a good description. And sound waves propagate in this manner. It will not be propagating through transverse wave or via transverse wave, but longitudinal wave. The correct answer is C.